So, I'm very glad that we host today in this diiP distinguished lecture seminar Professor Raul Castro Fernandez. Raul Castro is a professor at the University of Chicago. He got his PhD at the Imperial College of London, and then spent some years working at MIT before joining the University of Chicago. Raul belongs to the young generation of researchers, and thankfully, this young generation also comes with some new radical ideas. So today he's going to be talking to us about this new way of looking at data and the way that data flows in the different ways that we want to use and exploit this data, and how these data flows also produce market value. So all this is very interesting and also very relevant in today's society and context of computer science, where we have we can play a role in how all this evolves. But I guess this also has connections to social sciences, political sciences. So this is very exciting. Thanks for being here. The floor is yours.
Thanks so much, Demis, and thanks everyone for coming here to the talk. I'm really excited to be telling you about data ecology, which is the name that I've given to a research agenda that I started about 4 years ago when I joined the University of Chicago. As you see, it's a long title, lots of words there. I'll try to make sense of those as I go through the 40 minutes or so that I'll probably take today. As you see, the talk is going to be about data, which is a critical asset. It's critical to our economic, social, our cultural, and our technological environment, right? Infrastructure is powered by data. So you can think of entire industries, such as insurance or finance, that are built on data. We are all very excited about generative AI and more in general machine learning, and these are technologies that at core are fueled by data. These are services that are used by millions of users every day, and they are essentially paid with the data from those users. When you connect to Google, you are paying them with your data. It's a market transaction, perhaps not an obvious or an explicit one, but there is a market transaction there. And whenever we have a little bit of time and we spend some time watching a movie or listening to some music, we often take advantage of the recommendations that those services such as Spotify or Netflix provide us. And these recommendations are, again, built based on data. So I look across all those different scenarios, and I've sort of explained this in a way that is somewhat positive. But the truth is that in many cases, we look at the effects of data in these scenarios, and we actually don't like them. Right? Sometimes we like what data does. Sometimes we do not like what data does. Say that we're thinking about insurance, right? I like it when the insurance company where I have my car insurance bundles the service with my home insurance, because then it means that I am just paying less money and they are exposing themselves to less risk. So it's a benefit for me, it's a benefit for them, that's a win-win, we're all happy. Now, whenever that same insurance company taps into some data source on the internet, and they learn that perhaps I engage in some kind of risky behavior, imagine that they learn that I drive fast, that actually is going to have an impact on my premium. They probably will raise it because they think, well, you know, this guy is driving very fast, he's going to have some kind of crash, and then we're going to have to pay for that. Another example is the services that I was talking about earlier, right? These millions of users using those services, including myself, I use Google almost every day. I benefit from that service. I enjoy the service. It's helpful to me. It's not as good whenever the data that I'm giving those services ends up in a third party that I don't know about, and that third party decides to use it for something that might eventually harm me. So I look across those scenarios and I say, well, there's cases where we like what data does, cases where we do not like what data does. This is the motivational question for this research agenda. Can we reap the value of data while avoiding its harmful effects? And so as you see, it's a very broad question. It's not a research question. This is not concrete enough for us to attack it. And as a motivational question, however, I think it's important. I think a lot of the questions that we have today are around this concept of is data good or is data bad, and should we regulate the use of data, should we not regulate the use of data? When you have such a broad question, I think that you need some kind of insight, right, to approach the problem. And the insight that we've been exploring over these last few years is that we actually shouldn't be thinking about data, we should be thinking about data flows. And I'm going to use this slide to make that argument, and then I'm going to be building up upon that, okay? So what do I mean by saying we need to think in terms of data flows? Data is valuable. There will be some agents that seek access to that data, and in doing so, they'll cause data to flow. In the talk, when I talk about agents, I refer to, could be individuals, ourselves, it could be companies, it could be the government even. And when I talk about data flows, I have a very, very generic definition here. Okay, so there's some data D in some source, some function, arbitrary function gets applied to D, and that produces D prime. Whenever source and target are different agents, we say that is a data flow. And so if I take a file that I have in my computer and I copy it over to Femi's desktop, that is a data flow where the function needs the identity function because I've copied the data over. If what I do is I train a machine learning model and I provide some inferences to the world, the inferences themselves are a function of another function that I've run on the data. So that's another data flow as well. Okay? So that's sort of the way in which we're going to be thinking about data flows in the talk. So what I suggest is that you can look at any data environment, which is any scenario where agents are exchanging data, and explain whether agents like or dislike that environment based on the data flows that materialize. So when we say in the previous scenario that we like or didn't like the use of data, probably we're really thinking about the data flows that materialize. And what does like and dislike mean? It could be that we like the private or our privacy preferences are actually honored by the system. It could be that we trust the system. It could be that the system is producing welfare enhancing value for all of the participants. It could be defined in many different ways. Let me give you a few other examples to make this a little bit more concrete. And I'm going to start with TikTok. Again, this service that lots of people use on a daily basis. I might be okay giving my data to TikTok. I pay TikTok with my data to get their service. But I might not be happy about TikTok creating a data flow with, say, a foreign government, for example. That's a polemic that's been ongoing in the United States for a while, where people are arguing that perhaps the company is leaking data to other governments, right? You can think about Facebook. This is Zuckerberg. This is when he was in Congress about 3 years ago. And the senators in the United States were asking Zuckerberg whether Facebook was giving their data away to third parties. And so Zuckerberg was saying, no, we are not giving the data away. And they're saying, well, but you are making money out of the data from individuals. And he said, yes. And then the senators were puzzled. Thinking, well, how are you making money if you're not giving the data away? It's a 15-minute conversation where there's no progress. It's extremely chaotic. You can find it on YouTube if you are interested in. And I argue that if we had used the terminology of data flows, it's straightforward. If that's Meta is the new name for Facebook, right? If that's Meta and this is a third party, the key question was, is Meta copying over data from individuals to a third party? Or is it just letting third party create some kinds of run some functions on the data from individuals? And we know it's the latter, right? Meta is at least not purposefully copying the data over, giving the data away to third parties. They're just letting third parties query the data that they have. Which is not better or worse. I'm not trying to make that argument. I'm just saying it clarifies what is actually happening, and now we can evaluate, do we like it or do we not like it? So good. So I say that the insight here is, let's think about in terms of data flows and not data, and hopefully this will become even more clear why this is useful. But one thing that is useful to think at this stage is if we are saying that we can characterize environments by data flows, then a very natural question is, well, how do the data flows that materialize in a given environment came to be? And when you analyze those, you realize that sometimes it's just organically. You are doing your work and you are exchanging data with other agents, and that creates some data flows, and sometimes that data ends up in the hands of people who you do not like, but it's happening organically. And there are other cases where it's a set of knowing actors know precisely how they should pull data from you because they are going to be able to monetize it. So we find these two scenarios. And of course, what we do not like is when just a set of agents are taking advantage of that data, when in fact, we could redesign the system in a way that would be more helpful for more people. And that is essentially what takes me to the key thesis of what we call data ecology. The key thesis is that it is actually possible to design data environments by controlling data flows. And it seems like a very obvious follow-up from what I was trying to argue earlier. If I'm saying that when we like or do not like an environment is because of the data flows that materialize, then it seems reasonable to believe that if I were to tweak those data flows in that environment, I might make them so that I actually like the outcome. So data ecology is the set of principles, algorithms, systems, ideas that we are developing to make progress in this agenda of data ecology. And I'm going to give you a vignette of what exactly are we thinking, right? So let's illustrate the intuition by assuming a set of agents that are represented as nodes in that graph. And let's assume that each edge corresponds to a data flow that exists between those two agents. So in data ecology, we want to analyze existing data environments, for example, to understand that we may not like that data flow happening here, while here there isn't a data flow, but we would like a data flow to exist. That could be that I would like this agent to share their data with that other agent because it would be very helpful, but it's not happening. So this is the analysis phase. We want to provide interventions, make tweaks to the system so that the data flows that should not happen do not happen, and the ones that should happen do happen. And then the ultimate goal is to synthesize data environments where we essentially control what are the data flows that take place in a given environment so that the outcome is the one that we want. That's essentially the goal of data ecology. What I plan to do the rest of the talk is to make concrete what I've said so far, which is first, what does it mean to control a data flow? How can we do this? So I'm going to start by explaining one such mechanism of control. That's how we refer to the interventions that tweak the data flows that take place in an environment. And that mechanism of control is a data escrow. This is actually a software system. So I'll talk about that first as a perhaps more in-depth discussion of a concrete result that we have. And then I'll illustrate the many other ideas in data ecology to make more concrete the agenda and what are the goals of the agenda. Does that make sense so far? Great. So let's just jump in right into the data escrow, okay? So when you look at an environment today, if you work for a company or if you've done an internship, or if you think about how the government is managing your data, or the big tech platforms are managing your data, one of the things that is very obvious is that by default, data is overshared. And that is because every single time that you connect to some kind of system to see some data, because you want to query that data. So if you are this user, you have some data task. The moment that you connect to the data lake, where the data might be living, or a database, or Google Drive, or your business intelligence tool, whatever it is, you typically need to look at the data before you write a query or you write a program for that data. That seems very natural. When you do that, when you see that data, the data flow is already materialized, right? So if I see that data, it's as if I had copied the data over to my computer, and then I'm running the function. So what I'm saying here is that data flows are created by default today. That's the typical way in which systems, the way in which we've engineered them today works. And the reason why this is tricky is because once created, it is very hard to delete data since data is non-writable, right? I could show the data to 3 of you, and then I cannot go and remove it from your brain. I mean, once I've shown you the data, I cannot do anything at all, right? You have it, you can do whatever you want with that data, and I won't even know about it. And what I'm arguing here is that data flows are created by default. So there's a lot of oversharing, and that creates a lot of trouble. And so this data escrow system that we built is going to be dealing with this problem. But I want to illustrate first with a couple of examples why the previous is problematic. And so one example of a data scenario that we've studied quite a lot over these last 4 years is data markets, as Temis was saying in the introduction. So in these data markets, I'm going to simplify here a little bit the setup, and I'm going to just use a vignette where we have a seller, we have a buyer, and they might be interacting through one of these online marketplaces. This is AWS Marketplace, where you find sellers will list data sets that are for sale. Say there's a Finland consumer segmentation sold by Action for $11,000 US in this case. So if you're a buyer and you go to this site and you find a data set that you want, you pay for it, you get it. That's essentially the main idea. The promise is that if they worked well, perhaps it would be possible to take value from those who have access to data and distribute it to those who need access to data. That's sort of at least the most generous way of explaining what would be the potential value of these markets. What we find in practice after studying this quite closely is that it's actually very hard to make these data marketplaces work well in practice. As a seller, think about you're a seller, right? You have some data and you're selling this data. You're not going to release the data to a buyer until you get some payment. Because you know that once you release the data is released. It's non-rival, everyone has access to it. It's not like a car, right? If you were going to try to buy a car, you can try the car, and then probably they're going to force you to return the car if you're not paying for it, right? But with data, I just don't have a mechanism to force you to do that. At the same time, a buyer is not going to want to pay before seeing the data because then they don't know if that data will help their task. So there's a little bit of this catch-22 or chicken and egg problem here. You can think about a somewhat similar situation in the context of inside an organization. So if you've done an internship, you probably know that if you are playing the role of a data engineer, someone who's in charge of building a risk model or something like that, right? You may want to access some data that exists within the organization. And there might be some compliance officer that will tell you, well, you can't access that data because that data has sensitive attributes. And so you're not allowed to see those sensitive attributes. And so now you get into sort of this problematic situation where you're going to have to go through IT to secure access to the data after you justify what you're going to be using the data for. And then maybe after a couple of days, when people resolve the issue and you get access to the data, you realize that that was indeed not the data that you needed. You need something else, and you have to go through that process again. And the reason why this happens is because today, either I give you access to the data or I do not give you access to the data, period. Those are essentially the two blunt instruments that we have to operate here. So this already kind of points in the direction of where we are going, which is let's try to implement this key idea, which is it would be great if we could reveal the effect of materializing a data flow, but without actually materializing the data flow. In other words, it would be great if we could convince the buyer this data is going to help you without letting the buyer actually see the data. That's essentially the idea, right? If we were to do that, we would achieve the goal for data markets, we would achieve the goal for the case of compliance as well. So that's what we built this data escrow system for. It's a software system, as I mentioned earlier. If we use the example of data markets to illustrate it, and again, like this is a much more generic system. This could be used for many different scenarios. I'm going to use the data market one just because I introduced it. The sellers would send their data to the escrow, which is this sort of entity in the middle. The buyers would send their tasks to the escrow, and then the escrow would run the buyer's tasks on the seller's data. That's essentially the idea. The computation is delegated to the escrow, the data is delegated to the escrow. And the escrow makes a promise to both the sellers and the buyers, to the participants of the escrow. And it's that no data or derived data product is going to leave the escrow without explicit permission from the people who contribute the data in the first place. So let me make this contrast first, and then I'll go through an example to illustrate that idea, right? So again, in today's data systems, I was mentioning that if I want to query some data, I need to see the data first. If I want to query a table, I need to look at what the schema looks like so that I can write the SQL query. If I need to train a model, I need to understand what the data looks like so that I can load it into data frames. And when I do that, we already create a data flow by default, and that's a problem. With the data escrow, we do not see the data first. I just delegate my task to the escrow, and I trust that the escrow will somehow run that task that I've given on the data that I need. And so the result is that the data flow is materialized inside the escrow. So at this point, you may not believe how this happens. You may think like, well, how is that going to work? But at least you should believe that if I am not seeing the data, if I'm running the computation inside the escrow, it's true that I not get to see access to the data. At least that should be clear, right? So how does this help? Again, let's go to the market scenario. Let's assume that this is the buyer. I have a data task, which is, let's say I want to build a classifier of some kind. And I have already some training data locally in my organization. So when I train the data task with my own training data, I get an accuracy of 0.63. That's an example. Now I could delegate the task to the market, which is operated by the data escrow. The sellers could provide data to the market like they do today. And then we could allow the escrow to run my computation on that data, perhaps learning that with the additional data from certain sellers, we can obtain an accuracy of 0.94. At this point, I haven't told anything to the buyer. The buyer doesn't know anything about this yet. So now I get to choose. What information can I share with the buyer to convince them to signal what's the quality or the opportunity of using the market. So in this specific case, it might be the difference in accuracy, right? If I send the 0.94 to the buyer, now I'm the buyer, I know what I get if I don't get them access to the market. I know what I get if I get access to the market, and I can decide, is that differential in accuracy worth for me? And if so, how much? And am I willing to, what am I willing to do about that, right? So all what I've said so far is that before committing to give the data to the buyer, we're just finding a mechanism so that we can signal what would be the outcome of showing that data, to convince or to persuade or to incentivize the buyer to really let the buyer learn what is the private value for that data, right? So that's essentially one way. Again, this is a vignette scenario. I haven't talked about all the other issues that one would need to think about when designing an actual data market, and I'm happy to talk about that offline if people are interested in those questions. Here, I just want to illustrate the core concept around data flow, right? And that's sort of essentially how this would work. And somewhat similarly would work in the case of the data engineer and compliance officer. I no longer need to go through IT to secure access to sensitive data. I can just delegate my task, observe some signal that will tell me if that is the data that I need. And if it is, then I will go through IT and I will secure access through compliance as I normally would need to do. So what the escrow is enabling, if we go back to the question of data flow control, is conditional data flow materialization. I can actually get to see what the output of running a function on data is without seeing the data first, right? That's essentially the key thing that the escrow is enabling. Now, at this point, I basically have been relying on you believing that this works. I haven't told you anything about how do we delegate tasks, what does it actually mean, how do we create those signals, and so on and so forth. So I'm going to get a little bit, give just a bit of technical detail here, but it's just enough to get to hopefully to provide some intuition. And if you're interested in more details, I'm very happy to talk about those as well later. The key idea, and I'm very excited about this, is this concept of programmable data flows. It's essentially a programming model. We have an API, and we have a developer. Let's assume that the developer is someone who's not the agents that are going to be operating on the escrow. So I might be the developer, and I want to create an instance of a data escrow that allows other people to exchange data with each other, perhaps in the context of a data market, but perhaps in a different environment. The way in which I'm going to achieve that goal is by writing a program. This program is essentially bounds and specifies what the agents can do in the context of that escrow instance. For example, here we have some functions to compare schemas and combine tables, because I might believe that these agents are going to be working with tabular data, and I want to allow them to understand if the data that they are uploading will be compatible with each other. If it is compatible with each other, then I'm going to let them run some kind of machine learning model, in this case, an AutoML system, perhaps, and then I'm going to let them test the accuracy. And the reason why I may want to let them test the accuracy is because perhaps that's what I believe would be a good signal for them to learn what's the value of participating in this particular instance of the escrow. So as a developer, I write a program that essentially says, this is what this escrow instance can do. The program gets deployed on the escrow, and now the agents, the seller, the buyer, but whatever that the roles of those agents in the particular environment, they join the escrow and they start calling functions. And that's how they communicate. Every call to a function essentially generates a contract, where we will be saying, certain agent wants to access data that you've provided for doing X purpose. And now you get to approve that or to reject it. If you reject it, you can suggest what would be willing to share otherwise. And we call it contracts because we actually want that piece of code to have a legal interpretation. If someone wanted to bring an instance of a data set into court, the judge should be able to process those contracts and understand what exact amount of data was shared between the parties. So this is interesting because in a lot of these data sharing scenarios, you have compliance officers, auditors. There's lots of regulation around what data can be or cannot be shared. And of course, I don't need to convince anyone in Europe that that is the case, right? So it's very helpful to have primitives that actually are easy to interpret from folks from the systems that we are operating already, the legal system being one of them. And I'll talk a little bit more about that connection later. What I want to suggest here just is that with this data escrow and with this programmable data flow abstraction, I can basically envision how do I want this environment to operate? What are the data flows that I would like to take place? Who do I want to have a say on what data flows should take place? and then write a program that essentially implements one of those environments. Of course.
When you say the communication and logic, what do you mean by logic?
Yeah, great. So by logic, I mean the business logic of the actual computation. Like if I do compare schemas, what does that actually, what does that mean? Like how exactly are we going to compare them? And by communication, what I mean is if an agent decides to make a call to compare schemas, imagine that you and I are interacting and you uploaded some data and I want to compare schemas. It's your data, right? I'm not going to be able to do it unless you allow me to do so. That requires some communication, and the escrow is going to be essentially managing that. And if it's n agents, the same will be true. So these contracts will not need to be between two parties. It will be between n parties. Thanks for the clarification.
So one more question. In your example with the buyer, figuring out that that particular buyer can help them increase their accuracy. So how exactly does this work? So in order to compare accuracies, you need to operate on the same data, or how can you compare accuracies if the two data sets are disjoint?
So this is a great question, right? So it requires solving part of a data integration problem, part of a data discovery problem. I would say the gist of it is we do have a system that does the matching. If I write a utility function that describes what's good for me, whether it's training a machine learning model or running a what if task or some causal inference task of some sort, we have a system that will be able to tap into a set of tabular data and find combinations that when used as input of this task boosts the accuracy up. So as long as you can describe what you care about in terms of a utility function, which could, I mean, I use accuracy as an example, but it could be a combination of other factors, you can delegate that utility function and the system will find it. I haven't said anything about how that works because that would be part of the implementation here. But I'm very happy to tell you more about it. Like I actually have some backup slides on how this is meta. This is the name of the system. I can talk about that a little bit later if there's interest, if you don't mind.
Yeah, sure.
Great.
Okay,
because it's an interesting matching problem that is actually pretty hard, but it's another area that we've been working for a long time. So I'm almost envisioning that system will be deployed as a program that one could run. It's a great question. Otherwise, how that, like, it seems magic, right? Like, how does that happen? But I want to emphasize that it's a hard problem, but it's orthogonal from the control of data flows, right? Because it could be like a very simple computation that I'm doing, and that's already hard today. So it's essentially orthogonal from what the escrow is solving, but you already put the finger on how powerful will it be to connect these two concepts. So, okay, I want to say a couple of quick things about properties of the escrow, and then I want to jump into go back to the data ecology view, right? So we say that the escrow implements delegated computation, and I illustrated what I mean by that, the fact that I can submit a task to the escrow, and the escrow will run on my behalf. It has to be somehow trustworthy. There are lots of sources of trust, lots of ways of defining this quite complex socio-technical concept. The one that we use for the escrow work is we say, the escrow must maintain the guarantee that it made, which is that no data flow will leave the escrow without explicit permission from those who uploaded the data. And we say that it's quite a strong claim, because essentially we are saying that if someone were to hack into the machine where the escrow is running and read the data, that would be an unwanted data flow. That would be someone stealing my data. It's a data flow that I did not want to happen. We are basically saying that that is not possible with this design. Without getting into a lot of details, but just to give you the gist of how that would work is, we basically want to make sure that the data remains encrypted end-to-end, including during computation. And the way in which we engineer the system to achieve that goal is by leveraging hardware enclaves. So again, lots of technical details on how to make this work in a way that is not totally inefficient, and I'm happy to discuss those later if there's interest. But I want to emphasize one other important property of the escrow, which is this auditability. Anything that happens in the escrow must stay in the escrow. If you think about the escrow in the way that I've explained it, it's essentially logically centralizing data and computation. It's aware of all functions that are running on the data. So it knows the full provenance of what functions have been running on data. And that's very important if you are operating in some kind of regulated environment where someone might make a complaint, like Temis and I might agree to share some data, but it turns out that it's illegal what we are doing, because we are operating on medical data, say. So an auditor might need to tap into what is it that we actually were doing. Even though they were not adding data or running computation, they need to know what is it that we are engaging in. So it is precisely to allow auditors, compliance officers to see what are the internal operations that are taking place that we need this auditability aspect of it. Okay, let me step back. Okay, so I started talking about data ecology. I started talking about how we want is to look at an environment and control the data flows. So when the agents are operating normally, the goal that they reach is the goal that we want. And then I made the case that the data escrow is one example of what I call a mechanism of control. I'm going to define a mechanism of control as any intervention that controls data flow in a data environment. So the escrow is a mechanism of control in the sense that it's allowing me to see what the output of a data flow would be before I commit to it, so that I can then decide in a more informed way whether I want that data flow to exist or not. But what is the aim of data ecology? It's a lot broader than that. One very informal way of writing the problem statement would be, again, give me a goal and give me a set of mechanisms of control. And then I'll use those set of mechanisms of control. I will engineer them so that when the agents, like the agent's actions in that environment leads to the goal that I wanted. That's essentially the informal problem statement, right? Very informal. So from that perspective, the data escrow is just one mechanism of control. And in fact, I already used an example earlier where I said, maybe we want a data flow to take place here, but it doesn't. The escrow is not going to help with that. So we are going to need other mechanisms of control. So that's what I want to cover now. I'm going to quickly go over 4 remaining questions, and this is going to be a lot lighter than what we've discussed so far. And this is just me trying to illustrate what are some of the ideas that I believe are important in this research agenda of data ecology. So what other mechanisms of control do we need? That's the first question I'll address. Before I jump into that, are there any questions here? Is this more or less clear so far? So let's talk about those other mechanisms of control. And let's consider a different data environment. This is not a data market such as the one that I described earlier. This is a different one. We have 4 hospitals. Each hospital has access to some patient data. And maybe we would like those hospitals to share data with each other, because if they were to pull their data together, perhaps they would access to a better sample that would allow them to improve patient care, right? Very typical example of data sharing. The applications are vast, right? Pooling health data is one. Imagine fraud detection. If instead of hospitals, these are banks, and they are sharing the way in which people are attacking them, they would benefit from creating larger defenses, even though those banks are competing with each other. It's sort of like a cooperative environment. So data sharing is potentially transformative, and I think that is intuitively clear. It is also quite challenging. Consider a data flow, the way in which we defined it earlier. Maybe the hospitals want to run a function that runs a machine learning model on the pool data. But for that to be true, then this D needs to be pulled first. And of course, in the context of hospitals, each hospital is producing just a subset of the data. So we will need to somehow first take the data from each hospital, combine it, create the pool data, and then run our function. So far, so good. We could write a program that will do that with the programmable data flow data model that I mentioned earlier. The key problem, however, is that hospitals are not going to want to share data. That's exactly the problem that we are addressing here. It's not one where there's oversharing, which is what the escrow was addressing. It's one where they do not want to share data at all. They do not know what's the value that they're going to get from sharing, but they know that they're going to have to hire engineers, go through reinsurance, figure out what's going to happen if there is a data leak. It's a lot of risk, and they have no clear notion of what's the value that they're going to get. So they're, for the most part, disincentivized to go through the process of sharing, despite the upsides. So if we are the designer of this environment, and we would like them to share data, what we need to do is to find a way of incentivizing them to do that. And incentives then, of course, is going to be then a super important mechanism of control. It's not one that perhaps we think critically within the core of computer science, but it's one where economists have been making progress for many, many years. And so I think there is a huge opportunity here in bringing lots of the ideas from mechanism design, and we have many of those in CS. So just to be clear, I'm not saying computer scientists have not contributed to this area. They have contributed highly. What I'm proposing is that there are way other set of other ideas that we could bring in and recompile and understand how they can be deployed in systems to implement these incentive engineering ideas. So that's a lot of what we've been exploring as well. It's like, how can we incentivize people to share data? And I'm not going to get into the details of how do we do that in this case. just show you like what a deliverable might look like. And it might look like some kind of protocol where we have some platform in the middle. We have the different participants that could be hospitals, and we basically we make them go through a protocol where they get to learn what would be the value of sharing data, and we get to implement certain incentives so that, for example, we tell them, if you participate, your utility will be higher no matter what. It cannot be that you participate and you will lose money, or that you will, your engineer will not be well used. That's an invariant that we force on the protocol so that they are incentivized to work. And again, happy to chat about more about data sharing if it's needed. But incentives are another mechanism of control. Another question that one would ask here is, how applicable is this data ecology thing? Like, how is it true that you can always think in terms of data flows? How much can we do as individual researchers about this? I want to illustrate one other example, but it's very different from the previous ones. It's a different data market as well. And hopefully I get to talk about a little bit of privacy here as well. I'm very excited about this one. So this is a data market where I think all of us participate. We have individuals, and then we have the big tech platforms, Facebook, Google, Netflix, and so on. The way this data market works is individuals pay services with their data, and then the platforms monetize access to the data with the third-party data brokers, such as Axiom and Lexis. These are the main ones that operate in the United States. I'm pretty sure Axiom operates in Europe as well. I'm not sure about that, though. But there's a different set of data brokers that will be operating in Europe. So what happens with these markets? There are lots of challenges, one of which is that it is believed that the platforms are benefiting from the individual's data a lot more than the individuals themselves. And so some people say, well, this is unfair. So we should do something about that. What I believe is even more important is that individuals fundamentally cannot control their privacy because of the existence of their externalities. So here's an example that I typically use. I have never had in my life a Facebook account, never created one. And yet I know that Facebook probably has a pretty concrete profile of myself. Because guess what? I go with my wife to a restaurant and she takes a picture and I'm in that picture. Now, my wife agreed to a privacy terms that Facebook gave her when she created an account. So from their perspective, the privacy is granted. They agreed to that. But their decision has an effect on other people that were not involved, in this case, me. That's what I refer to as data externalities. The fact that if there is a data flow from one user to the platform, that data flow is allowing the platform to learn about a lot of other people who are correlated with the first one. We want to think about it a little bit more clearly, right? So on one hand, this externalities is essentially what makes recommendation algorithms work. You show me a song that you think I'm gonna like because someone else who likes other songs that I like that one, but I didn't know about it. But that same idea is also what is leaking characteristics of myself to this platform without me even being aware of it. So what do we do about that? So if we check this data flow lens and we apply it, and we do a little bit of data ecology thinking, one way to go about this would be to suggest a mechanism such as a data union, where we're going to have an intermediary between the individuals and the platforms. The intermediary pulls and intercepts all the data flows from the individuals, and then it decides what to release to the platforms. And so there are two consequences of this method. One is that it's absorbing the externalities. The union is absorbing the externalities instead of the platforms. And the second one, which is the one that I'm most excited about, is that it actually allows us to implement purpose-based data access, or for those of you who are interested in the philosophy of privacy, the idea of contextual integrity. So very, very quickly here, just to give another example, right? If my elbow hurts, say, and I call the doctor, I say, hey, my elbow hurts. Maybe the doctor says, send me a picture of your elbow. So fine, I'll take a picture of my elbow and send it to the doctor, and hopefully the doctor will use this picture to diagnose me. Now, if I get out the building in a couple hours and someone asks me in the street, send me a picture of your elbow, I would think that's very weird. And it's the same data that I'm sharing in both cases. It's the exact same data. It's just that the intended purpose, I suspect, is different when the doctor is asking me for that picture of the elbow than when someone random on the street is asking me for a picture of the elbow. That's a little bit what contextual integrity gets to tell us about. It's like, privacy should not be defined in terms of binary access. I give you access or not, access or control, which is how traditionally both philosophers and in computer science we've been thinking about that. I would say computer science practitioners, because of course privacy experts have a much wider set of ways of thinking about this, right? Contextual integrity tells us, well, we should be able to control for what purpose I'm giving the data away. So back to data unions. I'm an individual here. I could tell the data union, I'm giving you my location data, but I only want you to share the location data with Google to give me directions. But I don't want to share the location data with Netflix, for example. Or I don't want Google to share that data with someone else. If I'm intercepting everything in the data union, I get to control, because the union in a scenario such as this would be working on behalf of the users. That's essentially the idea. So it's all about like figuring out what kinds of things do we do to the environment so that we get to control the data flows that take place. So that the ones that take place are the ones that we like. And in this case, it would be, we are basically giving the individuals the opportunity to define where the purpose for which they want the data to be used. Okay. So this is mostly a teaser, because there's lots of problems here that I haven't mentioned how we go about, but I'd be happy to talk about this, of course. I use it on purpose as a teaser. I'll say though, there's this organization, Radical Exchange. These folks care a lot about data governance. They understand a lot about GDPR and other initiatives, and we've been working with them for like about a year and a half, and they wrote this article, Data Coalitions and Escrow Agents, where essentially they're asking, is there a possibility of implementing one of these data unions in real life by leveraging some of the ideas from the data escrow? So I don't see if you kind of see the link in between those two, but I think that there's a path, and we've been thinking about this quite hard. So I'm happy to share some of those insights as well. But I want to move a little bit ahead to cover the other ideas from data ecology. You know, when I give this example of the data union, some people ask, especially in computer science heavy departments, they ask, isn't this like a socio-technical problem? Why are you talking about incentives? That's what economists do. Why are you talking about privacy? That's what humanists do, which is a crazy statement to me, but this is something that I've heard. So I say, yes, it is a socio-technical problem. And I think as well, like we should actually be thinking about many of these problems as socio-technical problems and not technical problems alone. An example is in the community of data management, there's been decades of work in data integration, in data preparation, which is essentially saying you have two different databases from two different components. How do we find ways of aligning them so that we can operate on them? That's a simplified way of saying it. And typically, this problem is approached in a way that's automatic. You want a tool that does that automatically. Or maybe you are a human in the loop, but very carefully, so that you don't put a lot of effort on humans. And a lot of this data ecology lens tells you, but why? Why don't we think about the actual data flows? Where is the data flowing from? Who is going to know better what the data set means than the person who actually created the data set? Why don't we try to actually match the people who are creating data within an organization with the ones who are consuming that data? Maybe a little bit of communication saves us a lot of pain in figuring out how to align schemas, for example. So we are doing, we are starting a project here. It's been a few months now. We call it a NUMA data discovery system. And it's essentially this notion of how can we get an internal data market where we can make the information that the different agents have flow better among agents so that everyone has a better opportunity to use data proactively and effectively. And once we go the socio-technical route, we go all the way, right? So we think a lot about social norms, legal aspects, self-help, trust, privacy. These are extremely hard to grasp concepts that I think are nevertheless important if we are pretending that we're going to be making tweaks to some data environment, which these matter a lot. On the legal side, with colleagues from the law school at the University of Chicago, and this is, by the way, a very US-centric slide, but in the US, we have this concept of the treasury, which essentially appropriates resources from the public. So you raise taxes, and then these folks decide how the Senate decides how the taxes are going to be used. The treasury is keeping track of the flows of money, if you want to think about it that way. So what we're asking is, can we use the legal principles that already exist for controlling money? You've heard the follow the money kind of thing, right? What about follow the data? What about we create a treasury for data? What about we make sure that when the government is using our data, or companies are using our data, or they share data with each other, we actually are aware of that. Because if we, citizens of democratic countries, are aware of that, then we can actually modify it. We can say we do not like that this is happening, or we like that. We would like this other thing to happen, right? So we would have a say suddenly. And it's essentially like what we need to do to get there is we need to give politicians a vocabulary to think about data that goes beyond regulating AI. It's very grand and just too opaque and high level for it to be anything concrete and useful, right? While I do think there's a lot to do here, and I'm really excited about some of the guidelines that we are developing in this context. So just to give you a sense of how the ideas, and I appreciate that Dennis made that comment in the introduction, we're not just thinking about technical mechanisms of control. Many of these mechanisms of control, we've been operating with them for centuries, especially in Europe, right? The legal system. You can mandate data sharing. That's incentivizing a data flow to take place. And we should tap into those as well when needed, so that we can engineer these environments the way we want. Okay, so I'm going to give you a very quick teaser. I've talked a lot about data markets, and sometimes people want to know more about the work that we've done in data markets. There's a lot for different scenarios. We've been thinking about problems such as pricing, which is extremely hard, revenue allocation. If those are things that you've thought about or you're interested in knowing more about, let me know, and I'll point you to some of our work, or I'll tell you some of the ideas that we've been working on here. Traditionally, I've done a lot of work on data discovery as well. So you can think of data discovery as the data integration problem that I mentioned, where we are saying, I want to find data that helps my task automatically, right? So, for example, Metam would be the system that would address the problem that we discussed earlier, where I can just write a function, a utility function, and ask the system, find any data or any combination of data that will boost the utility. So we've been thinking about these problems sort of isolated from this angle of data ecology. But now moving forward, we are realizing that really, we should be thinking about what's the role that humans are playing when searching for data, when producing data, so that we can do a better job in discovering the data that's needed for solving problems. And so this is just to illustrate that all the technical work that's been going on over these last few years, I'm really very bullish on the conversion with this notion of data ecology and this notion of incentives. I think that is what's really going to make progress here. So good. So I'm going to wrap up in just a second. I wanted to tell you a little bit about what's next, right? So I'll give you some ideas of data ecology. What's next? Again, that's the thesis, is that it is possible to design data environments that reap the value of data while controlling harms by engineering data flows. And so I'll give you a few examples of those mechanisms of control today. In the next few years, one of the key goals that my group has is to distill generalizable contributions. So I am particularly interested in the first one. We are working on a theory and a systematization of the value of data. What's the value of data? We always talk about data being valuable, but it's very hard to know exactly what we mean by when we say that. And it's important in the context of data ecology, because if you remember the argument that I made at the beginning, I said that data is valuable, agents seek access to data, and that's what causes data flows. So if I want to intervene in the data flow, I need to know what is the cost of that data flow in the first place, or otherwise it's very hard, at least intuitively, it seems very hard to engineer those data flows and those incentives. So as I said, I'm very excited about what we are doing here. We have essentially a systematization that gives you a set of different interpretations of the value of data. And so if you take these and you have an environment that you care about, you can identify when you say data is valuable, which of the interpretations does it match, and that helps you clarify lots of ideas. That's at least the way we feel about this piece of work. Principles of data flow governance is the idea that I've been mentioning earlier. Given a goal and a set of mechanisms of control, tell me how can I engineer those mechanisms to achieve the goal. So that's we're working on what is the formalization of that idea. And then systems for data flow control. Of course, I talked about the escrow today. That's a particular software system. And we are working on a few others that we believe are also important for doing other types of interventions in these environments. Okay, and then at the end of the day, of course, we do all that because we do care about solving some real problems. I've mentioned a few applications that we've been dealing with. There are a few others that I'm very excited about. I've mentioned the internal data market with NUMA, but we are thinking a lot about what would it look like to build a data market for wearable data. I bought this Oura ring, like, I guess 2 years ago. This is like a wearable. It tells you like resting heart rate, you sleep well, sleep bad. It gives you a lot of that data, right? And it has an open API, which is what I like about it. Because it means that I could gather a lot of individuals who are willing to share this data together to either gain insights from each other or to expose that to, say, physicians or public health experts that might give you an insight such as, hey, in this city, people who live close to a highway have a higher resting heart rate at night. And so that means that perhaps there should be a public policy that either warns them about that or, you know, changes the price, or who knows what the public policy might be about. But I am just excited about what would it look like if we could design a market where I'm giving the data, but I actually get to control how the data is used. And my privacy matters first. It's not like, well, the platform will do whatever it wants with it, but I get to control it as part of the design of the market. And then I have a consortium of large language models. It's another example where, as you can imagine, it will be somewhat interesting to have smaller companies that maybe do not have the resources to build these large language models to be able to pool their resources with each other so that they can either combine their compute or combine their data or combine their insights. So I'm going to stop there with the thesis and with that picture of this is what happened when I asked Bing, the data generator, to write something for data ecology, engineering data flows. And at first sight, it looked like, oh, that makes sense. Look, there's some data and something is being created. But then when you actually start paying attention, it just makes no sense at all. Like it's extremely hard to know what these things are, like what those things are saying. But I found it funny, so I kept it there. That's generative data. Sure. Thanks everyone so much.
So are there any questions?
I mean, thank you for the very interesting talk. But maybe I missed this thing. But have you addressed the thing that you have the data you want to share to the people, but there are some certain group of people that you don't want to share because of the security or privacy issue.
Yeah. So
Can you repeat the question?
yes. So the question was, what about a scenario where you have some data that you would like to share with a group of people, but that group of people is just a subset of all the people who might get access to that data? In other words, I want to make sure that you have access to my data, but someone else does not have access to that data. So there is something fundamental about this that it's hard to address, which is that if I give you the data, I cannot control what you do with that data. You could give that data to the other person. And this is because, again, data is non-rival. One of the systems of control that we are working on that I haven't said anything today is actually a system to engineer rivalry around data. And that would allow me to transpass the responsibility of data to you, and then you get to choose what you do with the data, including giving it to someone else. But if I give it to you, then I'm agreeing to you do whatever you want with that data, right? So that's one angle. The other angle is, in many practical scenarios, the challenge is not as much that I want you to access the data and no one else to access the data, but rather that I want to control the release. I want to know exactly how much you learn about the data that I have. So I don't want to copy over an entire data set if, for example, all you want is an average of some property of some individuals. If that's all you want to do, then I'll compute the average and give you the average alone. That fine-grained control of data flows, right? Like if you think about it, if I copy the data over, that's a data flow. If I compute the average and I give it to you, that is also a data flow. I just change the function. But the fact that now I can control the function allows me to, with more fine granularity, understand what data am I exactly giving to you, and I should give you I should give you data that I'm only comfortable you sharing with others because that's something that you could potentially do, right? And so, in the context of data ecology, what we are studying is how do I create this mechanism to do this fine-grained control with you? And then how do we impose others so that you are disincentivized from sharing that data with others if that's my goal, right? So that's a lot of what we are thinking about. How do we combine then this mechanism of control to achieve this sort of more compound scenarios? So that's a good question. Thank you for that.
This is an ongoing work that
It is, yeah, exactly.
Thank you very much for the talk. I have a question regarding the design of the data escrow you presented. So the idea of the buyer is to submit a task and be able to gain some insight of what will happen if the buyer actually buys the data that's available. But I am not sure how is it possible to design a task without having an idea about how the data should be. And is this, for example, the schema of the data?
Correct.
So isn't this a problem?
Yeah. This is. Yeah, so I'll repeat the question. So that's a great question, right? The question is, hold on a second, like you're saying here that the buyer submits the task and then you'll get some insight on whether the task was useful or not, but how does the buyer know how to prepare the task if they haven't seen the data, right? If I don't see the schema, what SQL query do I write? I don't even know what are the names of the tables of the application. Remember this concept of programmable data flows. It's a little hard to wrap your head around at first, but the key idea here is that there is a third party, which is the developer, that actually gets to choose what functionality is available to you. Imagine you're the buyer and I'm the seller. So there's going to be some developer that will decide that sellers need to upload the data in CSV format. For example, I no longer get to choose what's the format. It's going to be CSV. That developer may decide that it's going to be impossible for you to write a task without seeing the schema. So that developer may decide to expose a function that just shows the schema.
But isn't this considered materialization?
It is. So the escrow is all about, like, the data flow has to materialize, otherwise no value gets created. The question is, do we get to control what gets materialized or not? And in this case, if I am calling a function that is only releasing the schema, and I agree that showing the schema to you is going to be necessary for you to write the task, then I might agree to do that, right? That's just one implementation, however. There are many other implementations that we could envision here, right? For example, rather than I show you the schema of my data, I will agree to some reference data, and I will just point to that reference data that happens to be public. So I don't even need to release anything internal, right? That would be a different implementation of this program. So to go back, your question is, how do I delegate tasks? How do I even know how to operate on data? The key question here is that there's going to be this developer that will actually bound the behavior of the agents in the escrow. So this has a positive, which is that it potentially solves the problem, a negative, which is that you depend on the program to be well written. I can write a very bad program that doesn't allow us to do anything at all. But that's sort of where evolving that program and learning how people are interacting with each other would go a long way here. And there's lots of practical scenarios where very few functions are already, like, think of a private cell intersection. That would be trivial to write in a program like this, right? So there are some primitives that are very high value that will become very easy to write with these programmable data flows that I'm moving. So that's a great question. And it always causes, it's always hard to wrap your head around because you're thinking, as the buyer, I want to have control on the function as well. But in many scenarios, you don't anyway. You just use the APIs that other people are offering you, the APIs that the libraries write. So all what we are saying here is the same. There's going to be some library provided by a developer, and that's what you need to abide for.
In the data sharing example, this data environment, what should be the data tasks there?
Are you thinking of the? Yes. So the question was in the data sharing scenario, and I'm wondering if you were thinking of the hospital data sharing. Okay, great. So the question was in this data sharing scenario, hospitals, what is the task, right? So the task would get defined by the individuals, right? By the individual hospitals. For example, the motivation for us to share data in the first place might be that I have a certain sample of patients with a very rare disease. I suspect that you have a set of patients with that rare disease as well. And you and I agree that our task will be to pull the data together so that we can increase the size of the sample, so that we can run an inference that perhaps will give us better statistical significance. So what is the task? It has to be decided between us. In the context of the escrow that I just explained, it's what would get implemented in the program. And in the context of the work that I just explained here, this is sort of what we published Sigmod last year, the task is just a parameter. So we did the evaluation with machine learning tasks, like I want to build up some classic multi-class classifier or some regression analysis on the data pool from different entities. But it's any task for which we have some kind of evaluation function so that we can signal the value of it. But I'm not sure that is addressing your question. Is that addressing your question?
You can consider the data flow control within the context of machine learning pipelines. Here you consider the example of data sharing system. In machine learning pipelines, you have several user profiles. Can you consider these user profiles, data scientists, data engineers, as agents?
Exactly. So the way I think about a machine learning pipeline, let's think about it in terms of an organization is you're going to have different titles. The marketing analyst who needs some insight about what campaigns should I be pushing forward, right? The data engineer who's going to be actually pulling the data from the original data sources to combine it so that they can so that someone else can create a model. The machine learning engineer who's actually going to be creating the model. Those data flows are the ones that in companies today are problematic because sometimes the market analyst will say, I want to create this campaign, but that requires accessing data that is sensitive. So the compliance officers whose work is to keep the company free of liability are going to say, don't share that data. So we're going to have to coordinate those agents. So all what I'm suggesting is that rather than thinking about the data, if we think about the data flows, as you are pointing out, at least we know what the goal is. And now we can ask, what things do we do to get to that goal? But if we think about the data, we get hooked up, I think, in questions such as, oh, this attribute is leaking too much information. What kinds of techniques can we apply to control the release? And I just don't think that fundamentally solves the problem. I think those set of techniques are useful for a different purpose. So in the context of hospitals, what I was envisioning here is that there will be at least one agent for each organization that serves a task with others. And the task would be, it could be increasing the sample size, as I mentioned, but it could be creating a machine learning model, whatever it is, right? But you're absolutely right that on the side of any one hospital, there are other data flows as well, because there's all this heterogeneity of titles that need to be involved to create these machine learning models, which, from my perspective, they're just a derived data product, right? Everything is a data flow. There's some training data. You create your function as a machine learning model, and that creates a data flow. So that's essentially the way I think about this as well. That's a good question. It's I think the complexity of data flows within organizations is sometimes a little bit harder to see, but it's obvious, right? It's so hard, and people have different mental models. And I do think that these kinds of techniques can at least help us be a little bit more clear on where the goals, and then we still need to figure out how to achieve them. And we've been working with a lot of these folks as well.
So we're over time, but I cannot help asking one last question.
Of course.
Just thinking forward on how these things can actually move into the real world. So I could very well see how a data escrow system could integrate in this marketplace of Amazon, right? And in this case, I guess Amazon will be incentivized to implement this because this gives value to both sellers and buyers. In the data union case, it's not clear how this will happen. And actually, in the example that you gave with Facebook, so your wife releasing information for you.
Right.
So who's gonna actually implement this, and for what purpose? So you're basically getting in the middle of the data flow between you and Facebook, which at this point is completely governed by Facebook.
Correct. This is a great question. So I'll try to be brief. I mean, I would like to talk about this for very long, but I'll try to be brief. Okay. So there are I guess there are two different ways of going about this problem, right? And traditionally, folks who work on data governance will tell you, well, sure, neither Facebook or Google are incentivized to change how they're not going to implement the data union because it's against their interests. And the citizens, we have no power whatsoever to change, to create a clean slate of some sort. In one branch, people will say regulation is looming, and if regulation falls into those data platforms, they might be forced to create a data union. That's the branch that I do not like, because I think first, I do not get to control what that regulation is going to say, or how is it going to be implemented, or actually what is going to be the effect, whether it's really going to create this data union or not. This is the one that I like. Take some powerful market player. We are using Apple. It's a market player that is powerful as those platforms, but unlike those platforms, does not make money out of selling data. A little bit money. The revenue stream are more the hardware cloud services. In addition, they've been selling privacy for a while. Apple has been including all these features to hide your email when you create a web account, all sorts of features for really protecting users. They're moving out of third-party cookies, all sorts of really big interventions to move away from there. There is one other key characteristic of Apple that makes it very interesting here, which is that if you want to write an application for the Apple ecosystem, you need to use their SDK, their software development kit. So they have an API. I want to access the step count from someone from the iPhone. I need to write an application against that API. So what we are doing is we are looking at that SDK and redesigning the SDK so that it's an escrow SDK. Where as a developer, I'm not pulling the data, creating that data flow, and then doing my work on my server and then giving it back to the user, because then I can send it to anyone else. I force the developer to send me the computation. And what is interesting about I think about this idea is, first, it's not clean slate. We are leveraging on an existing market layer. Second, we are only requiring to change the behavior of developers, and these are the ones that are more willing to change their behavior. Like if you've done JavaScript, I mean, there's like a new framework every week, and you need to kind of rethink how to create applications. So developers are very willing to change the way they write applications. It's a clear bottleneck because every application for Mac, for Vision Pro, for Apple, they all go to that SDK. So those are all the positives. The obvious negative is, what if Apple starts making money out of data? Then how do we now, like, we've made the union, we are basically relying on them being on the side of the citizens. But tomorrow they might turn. So that can happen, right? So I'm not saying this is lack of challenges. There are many. But I want to emphasize that it's not, some people think that I present this as a clean slate solution. And no, it's, of course, here it's presented as a clean slate, but we're actually thinking really hard. How do we move from that idea to something that we can deploy, at least for some small niche set of applications, and implement these sort of two key properties, including the purpose-based data access? Last thing, imagine that instead of just one union, there are conceptually n unions. There are 3 types. The type that protects your data 100%. The type that you don't care about your privacy, your data, you're okay with giving it to everyone. And one that says something like, I will not share any of your health or location data, but I'll share the others. As a user today, you have to be controlling every single access to data when you are using location or something else, right? Like the application will tell you, am I allowed to access that data? And that's actually quite problematic because there's a lot of burden on the user. So the additional thing that I'm suggesting then is that you could imagine how we would have a menu of unions, and the user would choose the union that express their privacy preferences the best. And then basically they're just delegating the execution of that purpose-based access control on that specific union. There's a lot of challenges there as well, but we do have an economic model now that shows that, at least in some scenarios, this can actually increase the social welfare for individuals. And I say it's an economic model because, again, the devil is in detail, right? Once we implement this thing, we'll need to see. But it's a great question. I wanted to, thanks for asking that, because I wanted to emphasize that we are really thinking hard. How do we actually make it real? And this is sort of the path that we've been exploring now for a while.
So that was very inspiring. Thanks again.
Thanks.
Thanks also to the people in the Zoom. We will close the Zoom session now.